second podcast in the thermodynamics packet. This podcast covers specific heat, and the target we're focusing on here is target number 2, calculate the specific heat of a substance and explain how that particular substance will conduct heat based on its specific heat. So specific heat capacity is defined as the amount of energy needed to raise, oh man, not good. Anyway, so really, it's the amount of energy needed to raise the temperature of, and here's the important part, it's 1 gram of a substance 1 degree Celsius. So 1 gram of a substance, 1 degree Celsius. All right, this basically tells you how easy or how hard it is to change the temperature of a substance in terms of the energy input-output. So really what that means is that high specific heat, change is relatively difficult in terms of energy. Low specific heat, change is relatively easy in terms of energy. Okay, so here's kind of what I'm talking about with some more numbers as far as that's concerned. So our next slide here, we're actually taking a look at some numbers associated with these temperature changes. So here's our question. How much heat in joules is required to raise the temperature of 7.40 grams of water from 29 degrees Celsius to 46 degrees Celsius? And we need to know something first, is that the specific heat of water is 4.184 joules per gram degree Celsius. So what that means is that for every 1 gram of water that we have, if we want to heat it 1 degree Celsius, we have to input 4.184 joules of energy. Or it works the reverse way. If we're cooling the water 1 degree Celsius, we're actually going to get 4.184 joules of energy from the water. Okay? So here's what we know about the problem. We know that we have 7.40 grams of water. The specific heat of water is 4.184 joules per gram degree Celsius. The initial temperature, temperature 1 is 29 degrees Celsius, and temperature 2 is 46 degrees Celsius. So we are trying to heat, we're gonna take this step by step. Let's say we just have 1 gram of water, and we want to heat it 1 degree. So we have 1 gram of water, so the mass is staying the same. All that's changing here is the temperature. So 1 gram of water heating up 1 degree. That requires 4.184 joules of energy. Now let's change the mass of the water from 1 to our desired 7.40 grams. We're still just heating 1 degree, but we're now heating 7.40 times as much water. So we use an equation here, 4.184 joules times 7.40 grams. This, when we multiply these two together, will give us the amount of energy it takes to heat this particular amount of water, 1 degree Celsius. Okay, let's add to our problem. We wanted 7.40 grams of water, and we wanted to see the temperature change from 29 to 46. So this is a 17 degree temperature change, not a 1 degree temperature change. So now we're going to change our little equation down here from 4.184 times 7.40. Now we're also multiplying by 17 degrees Celsius. All right. So when we change the temperature of water, we need to know the specific heat, we need to know the mass of the water, and we need to know the temperature change of the water. So the equation for this particular problem, mathematically speaking, is Q equals mc delta T. Q is heat energy. This is generally measured in joules. Okay, so those are parentheses and a J. If you can't figure that out, I'm not sure if I can figure it out. Doesn't look very pretty. M is the mass of the sample. C is the specific heat of the sample. Our textbook, if you actually look through that in the chapter on heat changes, which I think is chapter 10, which I'm not using it very much because the textbook represents this as an S, which really is, it's the only textbook I've ever seen use an S there, but C is specific heat of a sample. But in case you look in the textbook, it's an S. And then delta T, so delta is the Greek letter delta. It means change when you talk about it in a mathematical equation. So change in temperature, which is the final temperature minus the initial temperature. Okay? Heat's measured in joules. This is the SI unit, or it can be measured in something called calories. 4.184 joules is 1 calorie, and 1,000 calories is 1 kilocalorie, which is also 1 food calorie. So notice this C here is capitalized. Here it's lowercase. A capital C refers to actually a kilocalorie, and these are the calories that you ingest in food. So if someone has, say, a 2,000 calorie diet, they're eating 2,000 calories a day, it's really actually 2,000 times 1,000. So you could see that if we actually use small calories for food, the numbers would get really huge really fast, which I'm not sure why we use kilocalories and just call them calories, but maybe it's just because the big numbers would freak people out to see how many calories they were actually eating in a day. But maybe that's a good thing for some people. You never know. All right, example problem. Here's our example problem. It is to calculate the heat required to raise the temperature of 2.34 grams of water 10 degrees Celsius. So we got to write down what we know first. First, we know the mass of the water is 2.34 grams. And the other thing that we know is delta T, which is 10 degrees. We want to heat it 10 degrees. So hopefully 10 degrees proves to be a pretty simple number for us to use here because it's a nice easy number to multiply by, and it's degrees Celsius. What else do we know? We got an equation that we need to use, Q equals MC delta T, right? So we are trying to solve for what? Oh, we're trying to solve for Q, heat. Yeah, okay. So we need to know M, C, and delta T. Well, it looks like right now I only know M and delta T. If you were paying attention, though, we actually also know it's water. We know C. C is 4.184. Here's the true test of my penmanship here. 4.184 joules per gram degree Celsius. All right, that turned out all right. Not so bad. Okay, so we have to put all that together into an equation. 2.34 grams times, we'll do the C next, I guess, since that's the order it is in the equation I gave you. 4.184 joules per gram degree Celsius. Remember, there's a reason to write out all your units. And then our temperature change is 10 degrees Celsius. And when you multiply all this stuff out, your grams and grams cancel out, and your degrees Celsius and your degrees Celsius cancel out. And what does that leave you with when you finish this problem? It leaves you with an answer in joules. So when you actually calculate this out, 2.34 times 4.184 times answer, which I actually haven't calculated yet either, so I'm going to sit here and do it right while you do it. So take some time, calculate this out. And the answer comes out to be 97, actually right out of my calculator, 97.9056. Now if we look at sig figs, 3 sig figs, we're going to ignore 4.184 and 3 sig figs. So it's 97.9. So hopefully you're listening to this closely and you could hear this is 97.9 joules. All right. So apologize, not the prettiest of handwritings on this podcast, but that's pretty much it for the podcast. So I'll leave you with a little tunes from one of my favorite bands. And you can feel free to listen to this or just carry on.
Fashion, fashion, style. Look. I'm the edge, I'm the chic, I'm the taste. I'm a larger than life with just a President Reagan, Thatcher, Thatcher, Jazzercise, lip gloss. Ooh, you think you know fashion? Well, fashion's a stranger. You think fashion's your friend? My friend, fashion is danger. Posing at the bar. Posing sitting down. Posing in the distance. Posing with my arm. Posing with my leg. Posing like a swan. Posing for a portrait. Posing a threat. Hey, 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 yeah. Ooh, you think you know fashion?